Have you ever looked at a big spreadsheet just full of numbers and all you see is, well, just a bunch of noise? That's what we're going to tackle today. We're going to see exactly how we can transform a chaotic jumble of data into a clear, powerful story. Let's get into it. So we'll start with a super simple question, something you've probably seen 1,000 times. You pour a hot cup of coffee or tea. How does it actually cool down? I mean, does the temperature just drop steadily, nice and even? Or is there something a little more interesting going on? Well, we're about to find out. All right, section 1, from chaos to order. Every investigation starts with collecting data. And honestly, at first, it pretty much always looks like a total mess. So our very first job is to bring a little bit of order to all that chaos. Okay, so we've run our experiment. We've measured the temperature of our hot water at a few different times. And this is what we get. A completely random list of measurements. It's impossible to see what's happening here, right? It's just a jumble of numbers. But just watch what happens when we do one simple thing. Organize it. We just put all that data into a table. Time in one column, temperature in the other, all sorted from the beginning to the end. And bam, all of a sudden you can actually start to see a story taking shape. It's amazing what a little bit of structure can do. And this simple but incredibly powerful process, it's got a name. It's called tabulation. It's the absolute first, crucial step in making sense of your data. We're not changing any of the numbers. We're just arranging them in a way our brains can actually process. Okay, so section 2 is all about making data visual. Our table is a huge leap forward, for sure. But you know what they say? A picture is worth 1,000 words. To really see the story, we need to turn these numbers into a picture. So what's the best way to do that? How do we visualize the relationship between the time passing and the temperature dropping? If you're thinking of a graph, you are 100% correct. It's the perfect tool for the job. So to build our graph, we need 2 axes. Think of it this way. The horizontal one, the x-axis, is for our independent variable. That's the thing we control, which in this case is time. The vertical y-axis is for our dependent variable. That's the thing we measure, the temperature. It makes sense, right? The temperature depends on how much time has gone by. Now, you can't just throw some lines on a page and call it a day. A good, trustworthy scientific graph needs a few things. A clear title, labels on the axes telling you what they are and what units they're in, a scale that makes sense, and of course, the data points have to be in the right spot. These aren't just picky rules, they're what make the graph understandable to everyone. And now for the really fun part. We take each pair of numbers from our table, a time and a temperature, and we plot it as a single dot on the graph. We're literally building a visual map of what happened during our experiment, one point at a time. And that brings us to section 3, decoding the curve. Okay, all our points are on the graph. This is the moment of truth. The hidden pattern we've been hunting for is just about to reveal itself. As we connect those dots, something pretty incredible happens. What was just a bunch of separate points suddenly becomes a single flowing curve. This is the real magic of visualization. The graph takes all those little pieces of information and weaves them into one coherent story. So take a good look at the shape of this line. It's not straight, is it? It's a curve. What does that specific shape tell us about how our water is cooling? What's the story here? And here's our answer. The curve is really steep at the beginning, but then it starts to flatten out. That reveals the trend. The water cools down really fast right at the start, and then the cooling process slows way down. That is our conclusion, and it's based directly on the evidence. Okay, let's zoom out for a minute and look at the big picture in section 4, the power of patterns. What we just did with a cup of water, well, that exact same fundamental process is behind some of the biggest scientific breakthroughs ever. Seriously, think about scientists tracking global temperatures or doctors testing a new medicine. It always comes down to finding the pattern. And there you have it. This is the path. This 6-step process is the engine that drives science forward. You ask a question, you get some messy data, you organize it, you visualize it, you find the pattern, and then you draw your conclusion based on the evidence. We've literally just walked through the scientific method. And that's the key. It is one core process. It doesn't matter if you're looking at a cup of water or the path of a distant planet. This is how we turn simple observations into real knowledge. It's like the universal language of discovery. So the next time you see a set of numbers, don't just see data. Look for that hidden story. Because really, a pattern is just a narrative that's waiting to be discovered. The only real question is, what stories are out there waiting for you to tell?